Okay, maximization problems. You have 1,200 meters of fencing to enclose 3 rectangular pens. One side is along an existing wall and won't require fencing. Okay, so it would look something like that. So there's your 3 pens, and you obviously don't need fence on this side. Okay, so I'm going to go that whole side there is a length, and then those would be 4 widths. Okay, so 4W plus an L would total 1,200 meters of fencing. So I know that about the perimeter. So this mathematical sentence here, I want to isolate something, and I can tell it's be obviously easier to isolate the L than the W. So L equals 1,200 minus 4W. Okay, now let's talk about what we're going to be doing. Maximizing the area. So I know area is the length times the width. Okay, so instead of writing L, I'm going to take this statement and replace the L. All of that is still going to be times W. Okay, so this is my quadratic equation that I have to represent the area. So now, how am I going to use calculus to figure out the maximization? Well, we know that maxes occur when the slope is 0. So I'm going to derive this. And then I'm going to try to figure out where that slope is 0. So 1,200 divided by 8 is 150. Okay, maximize the total area of the pens. So depends on what the question says. It might say dimensions, it might say the area. So I do know that that's the width. If you have 4 of those, then that uses up 600. So now that would leave 600 meters for my length. And if I want to know the max area, then I could just multiply those two numbers. Okay, or I could have plugged 150 into this equation right there as well. Okay, you are selling tickets to an event. Tickets are $10, but research shows that 1,200 people will attend, and then if you reduce the price 50 cents, another 100 people come. So you're trying to maximize your revenue. So your revenue is your ticket price times the people that would come. Okay, so your ticket price is $10 and your people are 1,200. And then if you reduce the price 50 cents, another 100 people will come. Okay, but you don't know how many times you're going to reduce. So you might reduce once, twice. So we're going to put an X on that as well. And then as this changes, this also needs to change according to the same change. Okay, so now you would FOIL this out. So 12, and then this is plus 1,000x minus 600x minus 50x squared. Just going to rewrite it in order and then put these together. So now I'm going to use calculus. So this is the revenue equation. So derive it. So negative 100x plus 400. That's the derivative. And I would like to know, where does that derivative equal 0? So at x equals 4. Okay, so that doesn't tell me the actual answer, that just tells me how many changes you're going to make. That's all that would tell me. Okay, so if you make 4 changes of 50 cents, so that's what you're basically doing. 4 changes of 50 cents. So $10 subtract 50 cents 4 times ends up being a ticket price of $8. Okay, a sum of 2 positive numbers is 18. So x plus y equals 18. It's kind of like the fence question, right? You kind of get your one sentence. So I could say x equals 18 minus y, or I could say y equals 18 minus x from that sentence. Okay, we don't know, we'll just do that because we don't know which one we're going to use. Maximize the product. Product means multiply. The first number multiplied by 3 times the square of the second number. And then I want this to be a max product. Okay, so to me here, it looks like it'd be easier to insert something for x, because if I insert something to the y, then I gotta square it and times it by 3. So I'm going to take this sentence. So 18 minus y replaced. Okay, so the product equals, and I'm just going to distribute. So I'm going to go negative 3y cubed. And then 18 times 3, y squared, is 54. Okay, so I'm going to derive this. Negative 9y squared plus 108y. Where does that derivative equal 0? I think I can take out a negative 9y. So that leaves me with a y there, and 12? 9 times 12, yeah. So y would have to equal 0, or y would have to equal 12. And because the start said both the numbers have to be 2 positive numbers, so I can't have it being 0. So if my number was 12, and if y was 12, it would leave x to be 6. Okay, so those are my 2 numbers, but maximize the product. So 6 times 3 times 12 squared would be the max product. So the highest we could get is 2592. Okay. Alright, next you want to make a box by cutting out the corners of square paper and folding up the sides. So the paper is 16 by 16, and you're going to cut little corners out, and then once you've cut, you're going to fold that piece up, right? This is going to be empty. So this chunk folded up would be the height, right? Okay, so you're cutting a square off, so you're cutting an x by x off. So the volume is going to be, so the box here would have started at 16, and then you would have taken 2 x's off. So do you see that that side is 16, and then you would cut the x off, and then you cut another x off? You don't know, so you 16 minus 2x. Same with that side. And then the height, so when you fold it up, this is the height of the box, so X. So I'm going to FOIL this out. Okay, so 16 squared is 256. 32 times, and then another 32 makes negative 64x plus 4x squared, still times another x. So I'm going to write this in order, so I'm going to go 4x cubed minus 64x squared plus 256x. Okay, so now I'm going to, like we've done before, derive this to see where the critical points are. So 12x squared and then minus 128x plus 256. Okay, so that's the derivative. I want to know when that derivative equals 0. Okay, what can we do with factoring here? What can we divide everything by? Okay, I'm going to, well, let's just start with dividing by 4. So if I divide by 4, that's 3x squared. 128 divided by 4 is 32. 256 divided by 4 is 64. Okay, can't really divide anymore. Okay. Let's see if we can factor this, right? If something doesn't factor, you can always use the quadratic formula, right? Okay, so here we go. I'm going to loop this 3 times 64 is 192. What is 192 divisible by? (24 and 8). I found that. And that can get me a negative 32 if they're both negative. Okay, so under the 3, I could use 1 and 3. Under the 64, I could 1, 64, 2 and 32, 4 and 16, 8 and 8. So combinations that would get me a 24 and an 8. So I'm going to go through 8 and 8, both negative, and that should make it. So here x equals 8/3, which is 2.667, and here x equals 8. Okay, I do have to eliminate this as a possible solution, because if you think about cutting 8 off and another 8 off of each side, you started with 16, so now you've cut the whole side off. So we're going to cut that much off. So if the question says, well, this question just says how much should you cut off. If the question says find the max volume, we would do that. So we would go 16 minus, I'm just going to keep the 8/3 in there, and then square it, and then also times an 8/3. So if we did find the actual volume, 16 minus 2 times 8/3. Okay, so each side would be 10.67. So if you think about your box, it would be like 10.67 by 10.67 times a 2.67. Like that would be your box. But I'm going to obviously do it with exact numbers, so I'm going to square that, times it by 8/3. So that would be your volume if I asked you to find that.